Hey friends, and welcome to this week's What's the Math Wednesday, where I pick a math topic and I explain it. So today we're going to talk about the law of sines. Now this topic typically isn't in geometry, it's in Algebra 2 or Pre-Calc, but I always taught it in my honors geometry class, and I thought this would be a nice segue from right triangle trig. So today we are going to talk about law of sines when two angles and one side is provided. Now, you can also use law of sines when you know two sides and a non-included angle, but that's known as the ambiguous case, and that needs a video all in itself. So that'll be next week. So with the law of sines, the triangle does not need to be a right triangle in order to use it. And here's what the law of sines looks like. So if you look at this triangle, you have capital letters and lowercase letters that are the same letters as the capital letters. The capital letters represent the angles or the angle measures, and the lowercase letters represent the sides opposite of those angles. So capital A is angle A, lowercase a is the side opposite of that angle. So again, capital B is angle B, and lowercase b is the side opposite of angle B. So the formula is an extended ratio. We have three ratios equaling each other. When you do this problem, you're not going to have three ratios. You're only going to have two. So you're going to utilize proportions to solve. But what they're saying is the sine of angle A over the length of the side opposite of A is equal to the sine of angle B over the length that's opposite of angle B, which is equal to the sine of angle C over the length that's opposite of C. So that's what the formula looks like. Again, you're only going to have two ratios equal. It's not going to be three, but they're just saying that each of these ratios are equal. So like if you don't have angle A and lowercase a, but you have B and C and such, like that's why they give you this. Just as an FYI, all pictures and problems in this lesson are from Pearson's Geometry Text Book. This was a textbook I used in my high school. It aligned with the New Jersey state standards, and I really liked the examples that they had in there, and I thought this would be good for here. So thank you, Pearson, for your problems, and here we go. So this problem says in triangle ABC, the measure of angle A is 48, the measure of angle B is 93, and AC has a length of 15. To the nearest tenth, which is one decimal, what is the length of BC? Okay, so that's a lot of words. I always say draw out the picture first. So a couple things. We see that angle B is 93 degrees, so the triangle is obtuse. So when you draw this, make sure you draw an obtuse triangle. Now, it doesn't have to be to scale, meaning like if I took out a protractor, it doesn't have to actually show that it's 93 degrees, but you want to make sure that your picture at least looked obtuse so that you can draw this. So here we go. So here's the picture that goes with it. Angle A is labeled 48, angle B is labeled 93, AC has a length of 15, which is labeled. So what I'm going to do is on BC, I'm going to put a variable because I want to make sure that that's represented in this. So I'm going to put lowercase a because, again, it's the side that's opposite of angle A. So that's typically how you'll see certain things. So I might as well do that. So here we go. Now, applying the law of sines, we have the sine of 93 over 15 because, again, you want the sine of the angle over the side that's opposite of it. So sine of 93 over 15 equals the sine of 48 over A. So we know A is what we're solving for. What we're going to do next is apply cross products. So when you solve proportions, you multiply on the diagonals. That way you can get rid of the fraction. So A times sine of 93 is A sine of 93. And then 15 sine of 48. So we have A sine of 93 equals 15 sine of 48. You'd want to isolate A. Therefore, you would divide both sides by the sine of 93. And you would get that A equals 15 sine of 48 over the sine of 93. And you plug this in. to your calculator and you get 11.16247016, which they wanted us to round to the 10th, which is 1 decimal. So it would be 11.2. Now, just a reminder, because this is in degrees, you'd want to make sure your calculator is in degree mode, because if it's in radians, you're not going to get this answer. And also, just an FYI too, if you're going to like directly plug all of this into your calculator, make sure that you're grouping things correctly. So like you would do parentheses, 15 sine of 48, close parentheses. So the whole thing is in one parentheses, and then you would divide by sine of 93. Okay. And guys, again, if you have any questions on any of these examples, you can literally just comment and say like, how did you get blah, blah, blah in example 1, stuff like that. I definitely would love to help. Any more questions you have, or if you have another topic you want to see, just let me know. Okay, next example. So I wanted to do one that was a word problem because I know people have an issue with word problems. Sometimes they provide diagrams for you and sometimes they don't. And this is also like one of those real life application problems. So I thought this would be a good example for us. So it says a ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart along the coast. So that means from one lighthouse to the other is 40. At sea, the captain cannot determine distances by observation. The triangle formed by the lighthouses and the ships is shown, and I'll show you that in a second. I wanted to put out the picture on one slide. Can the ship safely sail to either lighthouse? I just flipped the words, but that's okay. So here's the picture. So we have it represented here that Port City Lighthouse to Covetown Lighthouse is 40. They provided us angle measures at Port City Lighthouse and at Covetown Lighthouse. So the one's 70 degrees and one's 52. And they want to know if the ship, which is located at the other vertices, can safely travel to either lighthouse. So what you'd want to do is first and foremost, solve for that missing angle, which is the ship angle. So we know that triangles have an interior sum of 180 degrees. So you do 180 and you subtract the 70 degree angle and the 52 degree angle and you'd get 58. So that means that the angle by the ship is 58 degrees. So you'd want to do that first. And the reason why you'd want to do that is because when you go to set up the proportion, you need an angle measure to go with that 40-mile length. So that's why. Okay, so let's solve first for the distance from the ship to Covetown Lighthouse. So I labeled that as X. So we have the sine of 58 over 40. So again, the sine of the angle over the length of the opposite side equals the sine of 70 over X. So we use cross products. So we have X sine of 58 equals 40 sine of 70. We isolate X by dividing by the sine of 58. So we have 40 sine of 70 divided by sine of 58. And that provides us with an answer of approximately 44.3. Now, they told us that we have 42 miles left. So no, in this case, we can't safely travel from where the ship is currently to Covetown Lighthouse. So that answer would be no. But we'd want to make sure that the ship could at least travel safely to Port City Lighthouse. So now we're going to do the same process with the Port City Lighthouse. Now, just as an FYI, I would always use values that are not rounded, meaning like, because we rounded this value, I wouldn't use it in the next problem. I would go back to using sine of 58 over 40 as half of the problem. And then I would do the sine of 52 over y. Again, I'm just picking variables for us just to represent the picture. So I have the sine of 58 over 40 equals the sine of 52 over y. I use cross products. I get y sine of 58 equals 40 sine of 52. I isolate my variable by dividing by sine of 58. So I get 40 sine of 52 all over sine of 58. And when I plug that into my calculator, I get approximately 37.2, which checks out because, again, we have 42 miles left. So that's not going over 42 miles, so we can safely travel from where we are currently to Port City Lighthouse. So that would be our answer. Okay, so now comes the point in this video where I give you practice problems. So here's the first one. So I'd like you to use the law of sines, which is what we've been doing, to find the values of x and y. And then I'd like you to round your answer to the nearest tenth. Again, that's 1 decimal. So here's this problem. Our two angle measures, in case this is fuzzy for you, is 63 degrees is the bottom left angle and 71 degrees is the bottom right angle. The bottom of the triangle is labeled as y, the left side of the triangle is labeled as x, and the right side of the triangle is labeled as 18. So solve for x and y for me and round to the nearest tenth. Okay, and then the second you do problem says the right fielder fields a softball between first base and second base as shown in the figure. If the right fielder throws the ball to second base, how far does she throw the ball? So you are solving for the length from right fielder to second base. And you're provided with these values. So the angle at second base is 68 degrees. The angle at first base is 40 degrees. And the distance from second base to first base is 60 feet. And why don't you round that answer to the nearest tenth as well? I'm sorry I didn't put that in there. But I know that I would have put that answer in the nearest tenth, 1 decimal. So I hope this video helps you guys with the law of sines when they provide you with 2 angles and a side. Next week, I will show you the ambiguous case, which is when they provide you with 2 sides and an angle. And as always, if you have any further questions or if you'd like to see a topic done, please comment and have a great day. Bye, guys.